So, Dennis, I've been reading your book, Dance to the Tune of Life, over the last couple of weeks. I think over the last few days, I think it's become known as my Bible, really, and I've been taking it everywhere with me. So there are a couple of things I wanted to ask you about. One is this idea of natural purposiveness, and some other kind of contentious phrases, new niche choice, and you also say that people who tell us there is no meaning or purpose in the universe are wrong, and you state that blind chance is not the only way. So I find these quite contentious, and you state that you're not letting God back in, but it sounds to me like you are.
Oh, I see. Okay. Right. So should I try and answer that?
Yes.
Yes.
Please.
Okay. Well, I see the difference as being this, that letting God back in is the idea that something is out there about which we know almost nothing, can know almost nothing, but which somehow directs the purposiveness in us. Whereas I take the view that the purposiveness is in organisms themselves. So I think the purposiveness is within us and within other organisms, not out there. So we were not constrained to do something by an intelligence out there, which is why I also do not go with intelligent design, as well as with the theistic views of creationism.
So if I argued that you're saying that almost that the universe created God rather than God created the universe, would you think that's going too far? I mean, you're saying that even microorganisms have this purpose.
Yes, because even bacteria can hypermutate their genomes in particular regions, which I regard as purposiveness in the sense that it doesn't mutate everywhere. But to put that to one side for a moment and go back to the question of, does the universe create God? You see, my difficulty is that I'm not at all sure what that means. I don't know what God would be if I met it. I don't know whether that means that therefore it doesn't make much sense to refer to it.
Well, I suppose I have the same problem with purpose. I'm not sure what purpose would mean if I met it. Okay. So what do you mean to say a bacterium has purpose?
Okay. Let me take something a bit sort of more likely to work for you. If I look at a heart cell and I ask the question, you see, how does that heart cell produce a nice cardiac rhythm? Electrical cycles that go like this are roughly once per second. Now, the interesting thing by that is that in order to reproduce that, I need to represent the processes in a whole cell. Because if I took the proteins and the metabolites and even put some lipid in a petri dish, I wouldn't get cardiac rhythm. So I'm arguing that arises because there is a cell that constrains the components to enable it to be possible for there to be rhythm. Now, I don't think that's bringing God back in, is it? I don't think God...
But you're not claiming that this is not an evolved state. I mean...
No, indeed not. I think it's an evolved state. Exactly. Yes. And I think, furthermore, that what has happened in evolution is that certain levels of organization have emerged. Now, I know that emerge creates problems for some people. I don't know whether for you or not. But it does seem to me that we have to recognize that certain phenomena emerge in the universe perfectly naturally. A tornado emerges from the natural processes of the movement of molecules in the atmosphere, creating clouds, creating movement of hot air and cold air, and eventually this extraordinary spinning top which is a tornado. And nothing creates the tornado, it creates itself.
No, I don't think I have a problem with that. I think it's words like purpose and choice that I have a problem with. And I suppose that could bring us on to the perennial, do you think there's free will? And obviously when we start talking about purpose and choice, to me that implies free will. To you it seems not.
No, I would go along and say, yes, it does eventually imply free will. You see, I wrote that book because I chose to do so. I think Richard Dawkins...
Well, you wrote that book because you think you chose to do so. But I don't think I don't think we want to go too far along that line. But
I understand you, but I don't think I just thought that I'd... That's a very nice one, Hagan, and I like it immensely. And I think that is eventually, though I'm not going there at the moment, not in this book anyway, I think eventually that is the big question. Do we have a kind of free will? Yes.
Well, I think certainly in your book you do admit we don't have all the answers at the moment. Yes, but let me just move on to maybe another topic. And another thing that you say that I find quite contentious is you say the idea of a super race is a political fantasy.
Right.
And of course nowadays we have all these amazing technologies like CRISPR, and one could argue that super animals and super plants have already been made, and I think many people would say that the future of this technology is basically boundless, limitless. So what do you mean by saying that a super race is a political fantasy?
Actually, I really mean that, Hagan, in a historical context. You see, I think the difficulty with eugenics, which is of course the idea that you can create a super race, was that originally, and we'll come on to the question of CRISPR and abilities to edit the genome in a moment, but originally the idea was that if you could breed from very intelligent people, you get a super race, and if you stopped the idiots and the insane and the criminals, and of course, as we well know, Jews and gypsies and so on, but let's leave that to one side for a moment too, you would eventually end up with a super race. Now, I think that is shown, has been shown to be a will of the wisp, an impossibility.
Well, that was 80, 90 years ago.
Yes, exactly. Yeah. So in the sense of looking for a super race, I was thinking very much of eugenics as it was conceived at the beginning of the last century. And I think that was a major disaster and a very bad, how should I put this? It wasn't good publicity for science either, because it led, as we all know, to some pretty terrible political conclusions and world wars. Now, you're right, the question, could one in the future imagine interfering with the genome in a way that you could create a super race? I'm not necessarily arguing against that. I am saying that it's going to be extraordinarily difficult to know what we're going to do. Because, I think because the connection between genes and the organism as a whole is not simple. And therefore, whenever you say, okay, I think I found a good gene here, and I found a bad gene there, so let's keep the good gene, let's get rid of the bad gene, I would respond to that by saying, well, wait a minute, we actually know that some bad genes are very good. Yeah. And, of course, sickle cell anemia is the one that's usually produced as the example. Sickle cell anemia is the fact that certain African populations carry a gene that produces a very strange result in their red blood cells, which makes it difficult to transport oxygen as effectively, but at the same time it protects them against diseases in Africa that are rampant. And so all genes, it seems to me, are likely to have this problem that some of the functionality they take part in is good, and some of the functionality they take part in is bad. The big problem...
I would argue there's a kind of sliding scale. I mean, if we could put the green fluorescent protein into Denis Noble, Denis would glow in the dark. And it's very simple, one gene, one outcome.
Yes.
And of course,
at that level, yes.
Cystic fibrosis or whatever,
Indeed,
again,
so, yes.
One gene background matters, but
sure.
Essentially one outcome.
Yeah.
But I think the feeling is now that once we have the sequences of millions of human genomes, we will be able to go, I wouldn't call it reductionism, one gene, one outcome, but we'll be able to understand the interactions between the genes. And of course, the CRISPR technologies are already amazingly sophisticated and can alter tens of genes at a time.
Sure. Yeah.
So I think that these early ideas that you would just knock out one gene or put in one gene are a bit dated now. Yes. I think we can do more. Yes. And the question is, of course, what is a super race? To me, a super race would be maybe a race in which we eliminated all diseases that have early onset. To someone else, it might be a super race, someone who can run 100 meters in 8 seconds. Yeah. So, even the definition of the super race is important. But I will bring you to task on the fact that you said this as a, fantasy.
Yes. No, I meant that largely
in a scientific.
Yes. No, indeed. I meant that largely in a historical context. But yes, you're right. But you see, I think the way in which you'd succeed in doing that is by understanding the relationship between phenotype and genotype. And as we know, that is multifactorial. Now, I think the way in which we would eventually succeed, if ever we do, in that would arise from an understanding of how the gene expression levels in, 25,000 or whatever the number is, of protein encoding components can be manipulated to produce particular phenotypes. And the difficulty, of course, is that understanding all of that is, should we say, it's quite a challenge. Because it's asking the question, see, how many interactions could there be between 25,000 genes? It's 10 to the 70,000. There are only 10 to the 80 molecules and particles in the whole universe, the whole known universe, of course, we should qualify. So we're dealing with extraordinary numbers of possibilities. And so I think we need to recognize, and I would modify what I said in the book. Mm-hmm. I'm perfectly happy to modify what I said in the book, incidentally, in the light of argument and discussion. But I would modify it to say something like that it's going to take us a long time to work that out. Now you're saying...
I definitely agree.
You're saying eventually we might, and then we could.
I think at a certain level we will. I mean, we've all, in terms of farm animals and plants, we've already created things that would be considered extraordinary 200 years ago.
Sure.
The question of whether we should do that with human beings, that's a really big discussion. But in my own mind, whether we can do it, I think we can do it.
Yes. I'm not going to say we can't, obviously. We just don't know. What I would say is this raises some very, very difficult ethical questions, because it really gets, doesn't it, at the essence of what it is to be human. And once we challenge that, we're doing something that is potentially very disruptive. Now, I'm not saying that that is not possible. Clearly, it might be. And I'm certainly not saying that it couldn't be a good thing. We just don't know. But I am saying let's be careful, because this is extraordinarily complicated, and there are some big ethical questions like what it is to be you and me. And I'm not sure how you and I would react to some of those possibilities when we think of it from a point of view of our own identity. And that's, of course, what humans in the future, if they're faced with this, are going to have to face, isn't it?
Well, it's quite... yes, I mean, I think we've already got used to the idea of our children being healthier and living longer, not necessarily for genetic reasons, for environmental reasons, so maybe this is something we can deal with.
Sure.
Well, Dennis, I like the end of your book. I like the last.
That's the bit I thought you might not like. You see,
I must say, I'd really buy into the science. I think there's an element of the straw man. I think that that practicing scientists all along were aware of all the complications of a simple Neo-Darwinism and the balance between all the different factors that you describe so admirably in the book. I mean, very clearly, it is still debatable, but I don't think many people would deny them.
They don't.
But I thought they may say they're insignificant, but they don't deny them. But I thought one question I had that you came up against at the end was really, as human beings, are there some things that will remain forever unknowable to us? And I always think of the example that other people bring up of the termites living in the termite hill, not knowing what's being recorded by the Hubble telescope and whatever.
Yes.
And I thought that you sort of basically admitted that, but I thought the way you dealt with that was very interesting, sort of quite kind of pragmatic.
It is pragmatic, actually, yes. It's saying that what we can know is what we work with. But there are quite a number of questions about which, certainly at the moment, it's very difficult to see how we... You see, to take one example, when the physicists talk to us about multiple universes, to get out of the difficulty which we have, that is that the constants that have to be used in the models of the universe that enable us to reproduce it from the Big Bang onwards are so finely adjusted. This is, of course, Martin Rees's point, that you're faced with a very difficult question. Did anything determine what those constants should be? And if it didn't, why on earth are they what they are? And if they are what they are and nobody determined what they are, maybe there are billions, trillions of universes out there that all have different constants, and we happen to be living, naturally enough, because otherwise we wouldn't be, in the one that happens to have the constants just as they are. Now, it seems to me that what that points to is, first, there are certain kinds of hypotheses that we produce in science, like the multi-universe hypothesis, about which it's extraordinarily difficult to see how we can ever get any information, empirical information, that would tell us whether that idea is correct. Now, I recognize that some people would just marginally disagree with that. Roger Penrose, for example, a very great physicist, will say, well, Dennis, maybe in that cosmic microradiation, the radiation that's the remnant of the Big Bang, there might be some structure, if only we can find it, that would tell us what happened before the Big Bang. And then you're beginning to get to, possibly some information about multi-universes. But that seems to me to be so remote that for the moment, at least, we can't see how we'd ever do it. Now, I say for the moment because I remember too, you see, that Auguste Comte in the 19th century, a great philosopher, said very categorically, we will never know the chemistry of the stars. Well, my goodness, he didn't know about quantum mechanics. Of course he didn't, because it came later. He didn't know that spectra would show us what atoms were present or not, what even molecules were present or not in stars. So the poor man just didn't realize that, in fact, we would know, not only the chemistry of the stars, but know that we are stardust. Yeah. We came spinning out of the sun to form planets, which eventually form us. So I'm well aware that it's dangerous to make a statement we will never know.
But if I was maybe to provoke you even more, if I said that, you know, given the track record,
yes.
which a part
yes.
of which you've just cited,
yes.
Would you close down philosophy departments at university? And you know, I guess my own feeling is that let's have the facts first, then the philosophy, and not the philosophy before the facts.
Okay. I go with the view that you need the book.
And I did say earlier that, Dennis, that I regarded you as a thinker, not a philosopher.
I understand. Yes, yes, I understand that. I sort of accept the term philosopher, but I understand what you're getting at, because there are respects in which I think philosophy has got something of a bad name for itself, and particularly, of course, from some of the statements about what would not be possible. And I go along with those who say, but you know, the interesting thing is that science always manages somehow or another to find a way forward. But I would add to that some questions really are conceptual in nature. And I think I'll give one example that I think is relevant to the book, which is this. Unless you accept that there is causality from higher levels of organization, it's impossible to understand what I'm saying in my book. Because, you see, I argue that for me to reproduce the cardiac rhythm, I have to take account of an organization at the level of a cell. And therefore, I think I have to have an agreement with a conceptual question, which is, does a cell as a level of organization exist? And I have to say yes to that in order for me to do what I do. So I think that one or two examples of where a conceptual question has to be answered before one can even begin to perform certain scientific investigations is perfectly reasonable. Now, I also think, and this is to elaborate on the interface between philosophy and science, that they're actually more intimately related than philosophers have tended to think. Because I think the big mistake in philosophy was to distance itself from empirical investigation, which it did. I remember arguing once with Peter Strawson, a great philosopher of, you could say, the Oxford School of Philosophy, which was,
yes, indeed,
everything lies in analysis of language, what is meant by. And in his book, Individuals, he wrote that you could only understand what it is to be an individual, a human, if you go along with particular philosophical arguments. Now, the difficulty I had with that, I once had to defend that view, incidentally, in debate with another major philosopher, Bernard Williams. And what I said about that was, you know, it's impossible to make sense of Peter Strawson's argument unless you also take account of the fact that it's necessary to say and assent to the fact that certain facts about humans are true, empirically true, that we can do X, we can do Y, and so on. And then you can sensibly ask the question, what is an individual, what is you and me? He seemed to be arguing, as it were, right up there, totally divorced from any scientific base as to what it might mean to identify an individual. I think that was wrong. And incidentally, it was a philosopher, Bernard Williams, who showed that it was wrong. And my view would be, of course there's bad philosophy.
Yeah. Well, there's bad science too.
There's bad science too,
yeah. All right.
But let's be clear, philosophy's role is not empirical investigation, but it should take account of empirical investigation.
Well, let me turn this on its head a little
Yes.
bit. I'm a practical person, as you know,
Yes.
and you've been pushing this idea of biological relativity. Let me ask you, what practical, what good things can this do for us?
Right.
So if we want to develop new medicines, if we want to construct new bacteria, or maybe even mammals or plants that could be useful to us, or if we want to go to sort of really far out, if we want to prevent violence or whatever. What does biological relativity tell us about all of these practical issues that confront us in the world?
Yes, I like that very much. Let's take, first of all, what can you do for medicine? See, the interesting thing is that the sequencing of the genome, which of course is partly predicated on the view that we would find hundreds of new targets. We have. I mean, we all know that. Hundreds of new targets for possible medication, but very few of them have actually been developed. Now, that may be too early. And so those who said that within 10 years after the year 2000 we would have cures for cancer, cures for dementia and so on, we're just simply over-calling it. But I think it's rather more than that. See, if I ask the question, how did Jim Black get onto H2 receptors and beta receptors, he did it through a very classical approach, which was take the phenotype, test certain chemicals against the phenotype and see what works. That's very practical indeed. Now, I also think that we could complement Jim Black's approach by saying, for goodness sake, do the genomics too. Because we've got a great technology now which enables it to be possible. As you said earlier on, you can identify the Duchenne muscular dystrophy problem in the genome. Absolutely right. And there are many other cases where that's true. So I would say you need to complement the Jim Black approach by genomics. I think he would have said that too if he was still alive today. So I don't think they're in opposition, but I do think you need to drill down from the high level. And the reason for that is my own experience. Many years ago, talking about my research team, looked at particular proteins that were responsible for modulating heart rhythm. And we came up with a very interesting discovery, which was that if you blocked a particular protein, you would get a very modest reduction in heart rhythm. A frequency change that is limited in the sense that it would not be possible with that block to stop the heart, which of course would be disastrous if you did it. Now, that was taken up by the Servier company and developed ivabradine, which is now a very good medication for those who have a heart rhythm that, particularly under exercise, is too fast. And we know how to actually bring it down, just gradually, in a very controlled way, with that particular drug. Now, I don't think we would have done that if we hadn't done the cell-level understanding of how the heart rhythm works. So I don't deny that genomics offers the possibility of many new discoveries, many new targets, but I would argue that we need the insight from the phenotype level to identify what would be worth doing. Because otherwise we have so many possibilities that we don't know what to choose from.
Do you think that perhaps there could even be a sort of different outlook on what medications might be? I mean, you might think from the sort of systems point of view, it's kind of absurd to have one drug, one disease, that you might have a particular condition, and if we could understand that at the systems level, you might administer, say, 6 drugs in different ratios and so on. Is there anything going on in that kind of area?
First of all, doctors do that already.
Well, they do in the end. They sort of say, that's not working, let's throw something else in. Exactly. Right.
But you see, they're doing it at the moment in a very serendipitous, chancy way. Yeah. As you say, let's try this, because this on its own didn't work.
Right.
Now, I think you're right. Eventually, it might be possible to ask the question, what would work? What is the combination? But you see, the difficulty is, I mean, people end up being treated, particularly in old age, with 6 medications. It's quite normal now. Now, out of 6 medications, the variety of combinations of the dose levels of those 6 is enormous. We all know that. It's roughly speaking 6 factorial, isn't it, which is pretty big as a number. Now,
but if I'm right, no one is really thinking about how these drugs work together. It's basically that they gave the first 2, things weren't quite right, we throw in another one, throw in another one. Yeah. Do you think there's any potential in doing something a bit more sophisticated?
I not only think that, I'm trying to do it. We are my own research group at the moment is actually working with multi-component medication. So I actually let my actions be where my mouth is, in the sense that I think that is well worth pursuing. I think that's exactly right. We've got to investigate multi-component medication. Now, that raises a big problem. You can't easily do the clinical trials. Because think about it. That number of combinations out of 6 chemicals, just 6 for the moment. How many clinical trials would you have to launch? They each cost 100 million. We are talking of the impossible almost, aren't we? Now, I think we then have to go back to something which was known to the ancients. You know, the way in which some medications emerged from folk remedies, I mean, I'm talking now about successful medications, was to put it in a jokey way, how many emperors did you kill? Now, that was the clinical trial. You see? And you leave those alone because those combinations clearly don't work. Poor emperor, gone. Now, this is a jokey way of putting it, but I think it is true to say that some of the output of that approach that has stayed with us is worth reinvestigating. Because in some cases it is now possible to show by clinical trial that it works. Now, one way in which you can approach that, which wouldn't mean killing emperors again, would be to say, well, you can build in silico clinical trials. In other words, you use the understanding you've already got of the way in which cells, tissues and organs react to multiple components or to particular components, and you calculate how they would respond to different proportions of the different chemicals, and you try to find the optimal solutions. And some drug companies are taking that up and take it up seriously. So I think there might be ways forward in the future. We can't kill emperors anymore, but perhaps we can find
maybe more positive, to go back to the old-fashioned way. I think that intimate knowledge of the patient is also very important. I mean, we've heard today on the radio about the 10-minute NHS appointment. I mean, how can that work in the context that you're talking about?
But I think that's as far as we can go, Hagan, isn't it?
So, Dennis, just to close, I suppose there are all these incredibly difficult issues in the world that, I mean, it's very obvious that Neo-Darwinism could not contribute to, such as violence and so on. Do you think that your outlook on the world ultimately might lead us to a better place?
Well, I suppose in some senses I would hope so, because I would hope that it would lead to an economics and a politics that is a bit more respecting cooperative behaviour. Now, that, of course, begs a large number of questions. Did the idea that genes are selfish create or lead to some of the more, how should we put it, inhumane attitudes? I don't know. I think that's going well beyond what I can say, but you're right to point to the fact that there are such implications in what I'm writing. I think that's right, yes.
All right, Dennis, I really enjoyed your book.
Thank you.
And it's, what can I say? It's, over the last couple of weeks when I've been reading it, it's really provoked a lot of thoughts in my mind, and it's gonna stay with me for a long time.
That was his intention, Hagan. Thank you very much.
Thank you.